video, I'm going to explain properties of components of vectors. You know, a vector can be expressed in the form of components. A vector is equal to axi plus ayj plus azk. Ax is the component along the x-axis, ay is the component along the y-axis, az is the component along the z-axis. B vector is bxi cap plus by j cap plus bz k cap. Now A and B are two vectors expressed in the component form. Suppose A vector is equal to B vector. If two vectors are equal, the corresponding components should be equal. Here x component is ax, here x component is bx. So compulsorily ax should be equal to bx, x component of the vectors. If two vectors are equal, x component should be equal. A vector is equal to b vector, then ax should be equal to bx. Then y component along the y-axis, ay, by. So ay should be equal to by. Similarly, az should be equal to bz. Now we'll see an example. F vector is equal to m a vector. Force is equal to mass into acceleration. So you are familiar with this relation. Force can be expressed in the component form fx I cap plus fy j cap plus fz k cap. There are three components: x component, y component and z component. Mass is a scalar quantity. Acceleration is a vector quantity. Acceleration can be expressed in the component form. So m ax I cap plus m ay j cap plus m az k cap. Now since f is equal to m a vector, then corresponding component should be equal. Fx, x component of the force, is equal to m ax. That means x component of the force should be equal to the x component of the acceleration multiplied by mass. So the force in the x along the x-axis is producing the acceleration along the x-axis. So Fy is equal to m ay. Then Fz is m az. P vector is equal to null vector. P, that is momentum. Momentum is equal to null vector. Momentum is a vector quantity, so it can be expressed in the component form: px I cap plus py j cap plus pz k cap. X component, y component, z component. Now 0 and so it's null vector. 0 vector or null vector. It can be expressed 0 I cap plus 0 j cap plus 0 k cap. Now when vectors are equal, their components should be equal. Here x component is px, here x component is 0. So px should be 0, py, here y component, here y component is 0. So py is 0, pz is equal to 0. When a vector is null vector, then each component should be equal to 0. In this example, two vectors are given to be equal. So you have to determine the value of t. Here j cap, that means only y component. J cap you take outside. So you will get a 5 minus t. So this side y component is 5 minus t. This side also only j cap is there. That means only y component. So take the j cap outside. So it will be 6 plus 3t inside. So 5 minus t is equal to 6 plus 3t. Now take this minus t the other side. So 3t plus t, it is 4t. Then 5 minus 6. So 5 minus 6 is minus 1 is equal to 4t. That means t is equal to minus 1 by 4. F1 vector plus F2 vector plus F3 vector is equal to F4 vector. In this example, we have to compare the components. So when the vectors are equal, then the components should be equal. Here F1 vector, its x component can be written as F1x. F2 vector, its x component is F2x, its x component is F3x. So we added all the x components this side. That should be equal to the x component of this vector, that is F4x. Similarly, this is the sum of the y components. F1y is the y component of the first vector, this is the y component of second vector, this is the y component of the third vector. You add everything, that should be equal to the y component of this vector. For F4 vector, y component is F4y. Similarly, sum of the set components on this side should be equal to the set component of this vector.